All right, so what I want to show you now is taking the letter A example, I believe it was, and I want to show you what it looks like when you graph these two functions on the same set of axes. So back to the tablet we go. Actually, okay, I wanted to get the functions written down on my slide there. Okay. First thing I notice is that I'm going to need a different scale for this. I'm going to have these go by twos. And even though I technically don't have to, there's a good reason I'm doing this. I'm going to have them also go by twos on the x-axis. Okay. So I'm going to use the slope-intercept method to graph these lines. Notice that I have rewritten the equation of f inverse of x. It originally looked like x minus 9 all over 4. You might want to take a half a minute or so and convince yourself that these mean the exact same thing. All right, starting with 4x plus 9. So we'll go to the y-intercept, which is 0, comma 9. All right, and then using the rise over run method, I'm going to cheat a little bit because I noticed that if I go up 4 or try to go up 4, I'm going to be off the screen. So this is a good trick to have in your bag of tricks. Instead of writing it as 4 over 1, I'm going to write it as negative 4 over negative 1. So this is going to be my rise. This is going to be my run. All right, so I'm going to go down 4, which is going to bring me to 5, and then I'm going to go 1 to the left. And if we do that one more time, go down 4 and go 1. Oh, wait a minute, I messed up. Forgot about my scale. Okay, I thought I was going 1 to the left. I was actually going 2 to the left, darn it. Okay, let's try that again. Down 4, that part was okay. And then 1 to the left, should only be there. All right, and then if I do that again, down 4 and 1 to the left, that should put me right there. All right, so if I do my best to draw a straight line, you know what? I don't think I've ever tried this before. I'm going to see if I can use a straight edge on top of my tablet. I'm a little nervous about this. I'm not sure if this is going to work. Yeah. Okay, well, it's not going to be perfect, but that's pretty close. All right, now I'm going to do the other line. So this is going to be a little tricky. We're dealing with fractions. The y-intercept is at 0, comma, negative 9 fourths. Remember, negative 9 fourths is negative 2 and 1/4. Okay, remember that my y-axis is scaled in 2s, so it might be helpful for me to just write a note here that that's negative 2, that's negative 4. And I want to go down to negative 2 1/4, which is going to be really, really close. Probably like right about there. All right, and then my rise over run is 1/4. So I'm going to go up 1 and then go 4 to the right. So up 1 will land me right about here. And then 4 to the right will put me right about there. And if I do that one more time, go up 1. Let's see, where am I now? I'm at negative 1 1/4, so that's going to put me at negative 1/4. And then go 4 to the right. That's going to put me right about there. And now if I try to draw a nice straight line through those points, I'll do the best that I can. It is going to look something like that. Okay. All right. So what I'm trying to show you is that when you graph a function and its inverse, you get a certain kind of symmetry, which may or may not be jumping off the page at you right now, jumping off the screen, I should say. The type of symmetry that you get from a function and its inverse is symmetry across the line y equals x, which is this line right here. This is the line y equals x. So the two graphs are always going to be mirror images of each other across that line. All right, and you can use that fact to draw the graph of an inverse function if you have the graph of the original function. All right, for example, given the graph of this function, which I have on the tablet, we want to graph the inverse function. So back to the tablet we go. Okay, so the first thing that I always like to do, there we go, is draw my y equals x line. Y equals x is a diagonal line. It goes up at a 45-degree angle through the origin. So draw that line as perfectly as you can. All right. And then when I'm drawing my inverse function, I like to identify some key points from the original function. For example, I notice that -4, 0 is on the graph of the original. I notice that 0, 2 is on the graph of the original. So if I switch the x and the y, that's going to put me at 0, -4, and it's going to put me at 2, 0. All right, so now, and then there's one other thing I'll point out. Whenever the original graph crosses the line y equals x, that means that the inverse function is also going to cross there. So that gives me 3 points that are on the graph of the inverse. So when I go to draw this graph, it's going to look something like, whoops, darn it. It's going to look something like this. All right. Well, we are almost to the end. Let's see what else we got. Yes, I think this is the last thing. So if f is a one-to-one function, and by the way, this is why we're covering this right after composite functions. If f is a one-to-one function, then the inverse of f is the function f inverse, such that f inverse circle f of x is equal to x, and f circle f inverse of x is equal to x. So you know what? I hadn't planned on doing this, but let me explain this in terms of the airplane analogy. Okay, I'm just gonna, now let's just start over. All right, so let's say that I have my original function f going from here. Sorry, my Alexa is babbling in the background. All right, and let's say the function f is taking me from x to y. All right, if I apply function f inverse, it should be taking me back to the original x. So if you look at f inverse of f of x, Okay, right now we're calling f of x y. And according to this picture, f inverse of y is equal to x. So it brings me back to the original x. In everyday language, this is just saying that when I fly back to Jersey for Christmas and then come home, I'm going to end up where I started. Now, every so often, my family in New Jersey comes to California to visit me. All right, so let's see how that looks. Let's say they got on a plane in, let's say, Philadelphia, and they take flight G to Sacramento. And let's say they start at X and end up at Y. Well, sadly, eventually the time for their visit is going to come to an end, and they're going to get on flight G inverse, which is going to take them back to the original X. All right. So this time, let's see, I think this time I want to start with Y. Let's look at G inverse of Y, because last time we had G inverse on the outside. Well, according to this picture, G inverse of Y is equal to X. And according to this picture, G of X is equal to Y. So they will also end up where they started. All right. Hopefully, this analogy helps you make more sense out of it. Okay, so the last example we're going to look at, is this one. If f of x is equal to the third power of x minus 5, let's show that f inverse of x is equal to the cube root of x add 5, right? Now, this is a little different from the problems we did earlier because they're handing me the inverse function and they're just asking me to verify it, to check it, all right? So this is a good way to check your inverse function problems, like the ones we were doing earlier, that 3-part problem that we did. So there are 2 things you have to do here. Number 1, you have to show that f inverse of f of x is just x, okay? All right, so let's do it. F inverse of f of x, remember f of x is the third power of x minus 5. And now what does function f inverse do? It takes a number, does the cube root of that number, and then adds 5. Okay. All right, so let's put that. I always think that it's helpful if we do a little bit of color coding with these. So let me put this in a different color. At least I hope it's helpful. Okay, so the x got replaced with x minus 5 cubed. All right, so now the cube root and the third power will cancel each other out and just leave me with x minus 5. And then, of course, x minus 5 plus 5 is x. Woohoo! We're always looking for that to come out to be x. If it comes out to anything other than x, that probably means something's wrong. All right, part 2 is to show that f of f inverse of x is equal to x. All right, so f of f inverse of x, we think that f inverse of x is the cube root of x add 5. And what does function f do? Let me color code this again. Sorry. Okay, cube root of x add 5. So what does function f do? It takes a number, subtracts 5, and then cubes the answer. So if we replace x with cube root of x add 5. Can you see how this is going to end? The plus 5 minus 5 are going to cancel each other out and just leave me with the cube root of x cubed. And of course, the cube root of x cubed is just x. Woohoo! All right. So our inverse functions are verified. And that's going to do it for section 12.2. We'll see you next time when we will start talking about exponential functions.